Thank you very much. Thank you, Ben, for that lovely introduction. Me and Ben were chatting, we were saying, seeing as I was the last speaker last year and the first speaker this year, we could just pretend like nothing's happened in between. Like I'd just literally carry on as though nothing's happened and we have a complete do-over and everything that happened in between, it was all just a dream. Alas, no. In this timeline, we must continue. So I would like to kick off Render 2017 by showing you some code. This is some code. This is a photograph of code. The code in this case is deoxyribonucleic acid. That's the code base. And the photograph is the famous photograph 51. This is taken by Rosalind Franklin, the X-ray crystallographer. The first time we could actually see the structure of DNA and able to figure out the code base. Right? She, in her notebooks, which you can browse online, which is kind of amazing, you can see these ideas forming, realizing that there is this underlying code base, right? Adenine, cytosine, guanine, and thymine, that when you put them together in different combinations, what you get is every single form of life on this planet. Humans, ants, elephants, redwood trees, you name it. It's all formed out of the same code base, right? Which is astounding. From such simple building blocks, you get such variety. And yet, amongst all that variety in nature, in biology, you do start to see trends amongst the successful species. There's a trend towards specialization, species that are really good at something through the process of natural selection. A trend towards ubiquity, right? Trying to expand your code base as wide as possible, to spread as far as possible. And this trend towards cooperation, that individuals aren't quite as powerful as a group of individuals working together in a species. So this is the general trend in nature, in biology, through natural selection, a trend towards specialization, ubiquity, cooperation. It's a slow process, though. It's slow and it's messy. All right, let's just kind of random mutations happen. They get sorted for fitness. It takes a long time. Now we've kind of got a bit of an edge in that we can sort of jumpstart the process and get ahead on enhancing ourselves through technology. Right? We get to augment ourselves through technology. This is an early example of technology, the Ashwalian hand axe. It's an example that stuck around for millions of years, right? A way for human beings to augment their hands so they could have a sharp cutting tool, right? Able to cut into things, to carve things, without having to wait for evolution and the process of natural selection. This is a colleague of Marshall McLuhan who said this, that we shape our tools and thereafter our tools shape us. And that's certainly true with technology. Yes, we create the technology, but then that technology has an influence on us. And it's interesting, if you look at the trends in technology, there's some similarities to the trends in biology. Take the pencil, which is a great piece of technology, right? It's got a great affordance. You can see which bit you're supposed to use. It's got a built-in progress bar, which is fantastic. It's even got the undo mechanism at the end, right? But it's a perfect example of technology exhibiting some of the same traits as we've seen in biology, like specialization. A pencil is really, really good at one thing, right? At writing. You can find pencils all over the world, right? The same fundamental design. And cooperation. The pencil is actually a great example of this. There's a short book called I, Pencil by Leonard Reed, where it's told from the point of view of a pencil. I am a pencil. And the point in the book is that no single human being can make a pencil. Not a single human. It requires cooperation. You think about, getting the graphite, and cutting down the tree to carve it, to make the wood, right? Getting it into the right shape. No single human being can do that. It requires cooperation. It's true of technology in general. It requires cooperation. You can attempt to make something on your own, but you're going to have a hard time, which is exactly what happened here with Thomas Thwaites. He's an artist here in the UK. You might have seen his most recent project, which was he attempted to live for a year as a goat. But this is an older project called the Toaster Project, where he wanted to create a toaster. That was it, just create a toaster, but he wanted to do it himself. He wanted to do everything from scratch. He was going to smelt his own iron, he was going to make his own plastic, and then he was going to get it to toast some toast. It actually worked for a few seconds before it just burned out. And it was prohibitively expensive, and as you can see, it's not really up to muster, right? So cooperation is kind of built in to any kind of technology. It's inherently a cooperative endeavor. So you see these parallels, right, between biology and technology. The specialization, the ubiquity, and the cooperation. And that can lead us to think that, okay, because they exhibit the same sort of traits, they're basically following the same process. And it's the idea that, with technology, we dream up a thing, we built it, that's also how biology works. But as we've seen with biology, it's this much messier, slower process, right, through natural selection. There is no guiding force in biology other than natural selection, which turns out to be an incredibly powerful force, amazingly powerful force. But with technology, it's different. With technology, we can think of the thing we want and then make it happen, which is very different to biology. Like, nature does not set out to create an octopus or create a duck-billed platypus, right? It's just, that's the current end result of evolution. Now, my favorite examples of technology where you dream up a thing and then you make that thing happen is a school of thought in Japan called Chindogu, which literally means like curious tool. And there's a manifesto behind Chindogu. The idea is that these objects need to be not exactly useful, but somehow not altogether useless. And this was started by Kenji Kawakami in 1995. I'll show you some examples, my favorite examples of Chindogu, where you look at these things and think, oh, that's stupid. But, actually, that's actually pretty clever, right? Butterstick, like, is it mad? Is it brilliant? Bit of column A, bit of column B, right? It's like, they're kind of great. Keeping your shoes dry in the rain, it makes total sense. If you have a toddler crawling around, why not use that kinetic energy to clean your floors? And it works if you don't have a toddler as well, right? But they are kind of ridiculous. You can't actually imagine these things in the real world, right? I found this thing in a Chindogu book from 20 years ago. Like, it's a stick you could put a camera on so you could take self-portraits yourself. Like, could you imagine anyone actually using this thing in the real world? So generally what you see with technology for millennia has been hardware enhancing humans, right? From a Schwalian hand axes to selfie sticks. You have the hardware and you have the human. You've got hand axes, pencils, toasters, Chindogu, trampolines, you name it. You got hardware, humans. But there's been a change in the 20th century where something new was introduced, and that's software. Where now you have a human interacting with the software interacting with the hardware, and vice versa. You have this intermediary between the hardware and the human. And I think a great example of these three factors working together to accomplish something astonishing would be the moon landings, the Apollo missions. By the way, this photograph here, seeing as we were just talking about selfies, this photograph is one of the few examples in existence of an everyone elsie. So Michael Collins is in Colombia taking a picture of Buzz Aldrin, Neil Armstrong, and every other human being alive at the time except for Michael Collins. It is literally an everyone elsie. Anyway, the Apollo landings are a perfect example of needing like amazing humans to actually go do this stuff, amazing hardware to accomplish it, but also, amazing software to get this done, particularly given the time, right? 1969. And Margaret Hamilton wrote amazing software, leading the team, writing the onboard flight software. And the trend kind of ever since is that we start to get the hardware fading into the background. It's almost like this is the end goal. The evolution of technology is to make the hardware fade away, become less and less important. So it's all about the software and the human. The idea of design dissolving in behavior. We talk about ubiquitous computing, which is really just an idea that the hardware is literally all around us. And we no longer even need to think about the hardware, and it becomes all about how we interact with the software. And this dream of trying to make the hardware irrelevant is sort of, in one way, what was at the heart of the World Wide Web. When Tim Berners-Lee was at CERN, everyone's using different operating systems, everyone's using different kinds of computers, and it's hard to get interoperability, right, between those different things. And that was sort of the dream he was chasing with the World Wide Web, is that it shouldn't matter what kind of hardware you're using, you still be able to exchange information. We kind of take it for granted today, right? Whether you got a Mac or a PC or an Android or an iPhone, that you can still access the web. The hardware doesn't matter. It's the software, right? And Tim Berners-Lee's technology is another example of a technology that builds on top of what comes before, very much like biology, right? You can't have the World Wide Web without the internet. You can't have the internet without computers, right? You can't have computers without electricity. You can't have electricity without the Industrial Revolution. So Tim Berners-Lee is building on the work of Bob Kahn and Vint Cerf, and they're building on the work of Alan Turing, who's building on the work of Faraday and Davies, right? It's all this layers and layers of technology. What's interesting is when you see this kind of evolution, this process of technology, first of all, you start to notice there's certain times where things can't be invented. Stephen Johnson talks about this idea of the adjacent possible, why you couldn't have invented the microwave oven in 15th century Holland because there were too many other things that needed to happen before you could make a microwave oven. But once you have all these things in place, things become, if not quite inevitable, then it's only a matter of time that if one person had invented it, somebody else would have done it. Now, once we had industrialization, electricity, and computers, something like the internet was going to come along. Maybe not the internet as it turned out we've got today, but something like it was bound to come along. And something like the web was probably bound to come along on top of the internet. But we got the web that Tim Berners-Lee created, which is created out of these building blocks, right? HTTP, you'll be hearing a whole lot more about HTTP next from Anna. You got URLs, and you got HTML. Now, creating new formats and creating new protocols, new ideas, that's actually not the hard bit. The hard bit is convincing people to use them, right? There are plenty of other protocols out there, and there are plenty of other formats. How do you convince people to use them? And this reminds me of something that Grace Hopper used to say, that amazing programmer Grace Hopper, inventor of COBOL, inventor of the compiler, a huge contribution to our technology today. And she used to say that humans are allergic to change. Right? It would frustrate her. She had the most frustrating sentence in the English language is, "We've always done it that way." Right? Trying to convince people to change can be really, really hard. And so Tim Berners-Lee knew that to convince people to use these building blocks of his project, he had to keep them familiar. So that's why they're built upon familiar building blocks. Right? HTTP is built on top of TCP/IP, building on the work of Bob Kahn and Vint Cerf, and URLs use the domain name system. There's already been decades of work done there. And HTML, the format, was actually pretty much just a ripoff of this existing format that everyone was already using at CERN called SGML, right? In fact, if you looked at SGML at the time at CERN, it was a markup language and it had these elements in it. Look familiar? Right? So Tim Berners-Lee just took these elements wholesale. In fact, you were able to take, at the time, you could take an SGML file at CERN, change the file extension to .htm, and open it in a web browser, and it would pretty much work, right? Because browsers would just ignore the bits they didn't understand. So that was kind of a stroke of genius in terms of adoption of technology, is like make it easy for people to adopt it. It's kind of the same with Sass, right? Because you think you can take any CSS file, change the file extension to .scss, and it's automatically a Sass file. And now you can start to tinker with it, right? So this is a really clever approach. And then over time, of course, we can start adding in new elements. We can enhance the richness of HTML, and we get a whole bunch more elements that add meaning to the content that we're marking up, right? So we get new semantics in the language. But of course, where it gets really interesting is where we get new behaviors in the language, where we start to make more powerful additions to HTML, things like video and canvas, audio, all this stuff, right? If you dive into the design of these elements, they aren't just thrown out there like, yeah, we think this will work, because there's a lot of thought has gone into making them, yes, making them work, making them powerful, but also making them backwards compatible. Like the design of video, canvas, audio, all these things, between the opening and closing tags, you can put in fallback content for the browsers that don't yet understand those elements. And that's not an accident, right? There are principles guiding the design of the language, literally the HTML design principles, which state that the document conformance requirements should be designed so that web content can degrade gracefully in older or less capable user agents, even when making use of new elements, attributes, APIs, and content models. Right? So it's no accident that backwards compatibility is built in. And it turns out when you've got backwards compatibility built in, there's more reason for people to start using the new stuff, and you get wider and faster adoption. I really like the HTML design principles, but I'm kind of a sucker for design principles in general. I'm a bit of a nerd for design principles. I collect them. I've got a URL, principles.adactio.com, and I keep the design principles from software companies, from organizations, personal design principles by people. You can find the design principles for Chindogu listed there as well. Principles fascinate me, but I think because of where they sit. If we're setting out on any endeavor, technological or otherwise, you need to begin by having this vision, right? You've got the goals, what you want to accomplish. And then those goals, for example, we want to make hardware irrelevant at CERN. Those goals influence the principles, for example, the HTML design principles. And then the results of the principles are the patterns, the individual building blocks we then use. In the case of HTML, it's the elements, right? And so we have these really powerful elements. And we might look at them and think, okay, there's a really important question we need to ask if we're going to use some piece of technology like this, which is, how well does it work? Seems obvious, right? Whenever we're evaluating a piece of technology, this is the question to ask. How well does it work? Does it do what it says it's going to do? Is it powerful enough? But I think that's only half the story. The really important question to ask is, how well does it fail? What happens when it doesn't do what it says it's going to do? Does it matter? Does it fail well? Let me give you an example, from a more up-to-date example. CSS shapes, okay, landing in more and more browsers. And you might go onto Can I Use, and you see a fair bit of green, which is good, but you also see some red. And you think, maybe that means I can't use it because it's not white, it's not supported everywhere. But the red and the green doesn't actually answer the question, how well does it fail, which is really what matters here. So if I'm using CSS shapes, I've got it on my website, and you can see, okay, I've got some text wrapping around in a circular shape there, right? Also using a border radius on the image. But what happens in a browser that doesn't support CSS shapes? What happens in the red browsers? In other words, how well does it fail? Well, in those browsers, it just goes in a straight line down the side of the image, which is absolutely fine. It's pretty much what I would have had anyway. So it fails really, really well. So the red and the green doesn't really matter as much as asking how well does it fail. And that's what can help you make the decision when you're evaluating these technologies, whether to dive in and start using them. So let's take that lens, let's take that question, how well does it fail, and apply it to some of the buzzwordy, hyped technologies we're hearing a lot about these days on the web. Let's take service workers. I am personally very excited about service workers. There's a lot of talk about service workers at last year's Conf. I won't go into the details of what it does exactly, because it's kind of voodoo magic. That basically you can install this thing on the user's browser that can intercept network requests. It's like you're doing a man-in-the-middle attack on your own website. It's incredibly powerful, and if nothing else, it means you can have your own customized offline pages, as well as no-brainer stuff like you can cache stuff like images and style sheets and scripts and stuff. It's really good. It's really powerful. Like on The Guardian, they've got an offline page where you can play a crossword puzzle. If you're trying to read an article but it's offline, hey, play this crossword puzzle. Really nice. Okay. So first we might ask ourselves, service workers, all this hype, all this promise, how well does it work? I think it works pretty well. I've messed around with service workers. There's a barrier to entry. You've got to make sure your site is running on HTTPS, but that's no bad thing, right? So that's good. It doesn't do any magic for you, like right out of the box. It's not going to do anything. You have to tell it what to do. In other words, you have to kind of write the recipe for the service worker to follow. But then it does work pretty well, and you start using these other APIs like fetch and cache and the notifications API even. But you kind of have to do the heavy lifting. But it does work pretty well. I mean, the occasional bug and stuff, but not bad. Now, if we look over at Can I Use and we see the support, it's like, yeah, pretty good. Lots of green, but also lots of red. Some glaring omissions there in the support. And I've seen people look at this and go, I'm not going to use service workers because just look, there's no support on some platforms like Safari, for example. Therefore, I'm not going to use service workers. But that's missing the important question. How well does it fail? So how well do service workers fail? They fail great. It's kind of built into the design of service workers that, okay, so here's the way a service worker works, right? I visit your website for the first time, and I download a page and stuff, and in amongst that, I also get a service worker, and it gets installed, and then every subsequent visit, every subsequent request after that, the service worker can do its magic. But remember, that first visit, there is no service worker. So every browser, no matter whether it's red or green on that chart, every browser is a non-service worker browser the first time someone visits your site. Therefore, you have to account for that. Therefore, you literally can't make a website that relies on a service worker. You can only use service workers as an enhancement to what you've already got. So how well does it fail? It fails great, because any browser that doesn't support service worker just carries on as it's currently carrying on. There's literally no difference. There's no harm done in the lack of support of service workers. And then it becomes a no-brainer to add service workers to the browsers that can support it. They get a little boost, and over time there'll be more and more browsers getting that boost. So I would say service workers fail really, really well. Let's take a look at some other technologies. Web components. All right, there was a whole workshop on web components yesterday. And when I'm talking about web components here, I'm talking about the specific set of standards. Where web components isn't, one thing. It's this combination of things like custom elements, and other standards like the shadow DOM, and then you've got HTML imports and the template feature in HTML, and then web components is kind of this umbrella term for all of these underlying technologies. So the idea is that just as in HTML we have these powerful elements that have these behaviors associated with them, right? Canvas, audio, video. That with custom elements you could just go ahead and create your own powerful elements that have behaviors associated with them. The only caveat is you've got to make sure there's a hyphen in the element name. There's this kind of agreement between developers and future browser makers that there will never be an HTML element that has a hyphen in it, therefore it's kind of a safe namespace for us to use. As long as it's got a hyphen, we can do it. Okay, so you just go ahead and you make a custom element. Like I'm going to make a menu element. Now, at this point, it's literally just a span. It's like you've just told the browser a meaningless element. The other parts start to play in when you have the HTML imports, where you can point off to another file, and in there you've got your HTML and your CSS and your JavaScript for this new element, this web component, and it's encapsulated. Now, this is kind of the dream we've been chasing for years, right? The CSS inside this web component won't leak out, and the JavaScript won't leak out. You won't get this clash of namespaces and stuff, which makes it really reusable and really portable. You can write a custom element, a web component, and then I can take it en masse and just drop it into my site, right? This modular, componentized approach is something we've been chasing for a long time. And now it seems like it's becoming a reality in the standards. All right, how well does it work? And when we look at the support for, let's say, custom elements, just one part of the web component stack, we see, okay, there's some off-green colors there, a bit of green, but a lot of red too. But as we saw, looking at other technologies, this isn't the real picture here. What matters is how we answer the next question, which is how well does it fail? That's where it gets really interesting for web components. Because there isn't really a single answer to this question when it comes to web components. The answer to how well do web components fail is it depends. It depends on how you design your web components. It depends how much thought you put into backwards compatibility. So here's a nice example I saw Adam Anishi blogging about, where let's say I've got an image gallery web component custom element. What I could do is make sure that in between the opening and closing tags, I've got the images that are going to be in the image gallery. Now, with my HTML import and my encapsulated JavaScript and CSS, I can then turn this into a beautiful carousel with behaviors and swipes and all this animation associated with it. Great. But in browsers that don't support that stuff yet, you'd still get the images. So if you put some thought into it, you can make web components that degrade well, right? The same way that HTML elements degrade well. But when I look at the examples of web components out there, I'm much more likely to see this. Opening tag, closing tag, and that's it. In fact, there's a showcase site for Polymer, which is a library of web components, where they've made a shop. And this is literally the entirety of the body of the document, right? An opening shop app element, closing shop app element script. And that's where all the magic happens, right, is in the script. There's no backwards compatibility there. So the answer to how well does it fail is entirely in the hands of the person writing the web component. Now the good news is it's early days. with web components. So we could steer the course. We could set out, best practices, including, backwards compatibility. The very exciting thing about web components is that they give us, developers, power that was previously only in the hands of browser makers. But the really scary thing about web components is that it gives us, developers, power that was previously only in the hands of browser makers. And we need to match it with responsibility. Maybe we need to have design principles in the same way that, the HTML format itself has design principles. Match that responsibility, that power with responsibility. Now, both of these technologies, service workers, web components, they have a commonality in that they're both kind of these umbrella terms for lots of underlying APIs that are kind of deep in the browsers. So service worker itself is kind of, this way of accessing fetch and cache and notifications. And web components is made up of custom elements and HTML imports and shadow DOM and all this other stuff. And the idea here is that instead of the standards bodies in the browsers, trying to anticipate what developers want, specifying it and shipping it, that instead we give developers access to the low-level APIs. They go out and make things, let 1,000 flowers bloom, and the really popular ones, the ones that show themselves to be robust, find their way back into the standards. That's the theory. Like in the past, service workers is not the first attempt to have some kind of offline technology in the browser. There was previously app cache. I don't know if anybody's tried to use app cache, but it's not fun. You're going to have a hard time. And it's partly because of the design of it. It was designed in isolation and then spec'd and shipped. And then developers went, this is not what we need. This is not what we want. So it was a real learning moment where we kind of realized what we need to do is give developers access to the low-level APIs, let them figure out what's useful, what works, and then bring those learnings back into the standards. And this is all part of this kind of overall movement called the extensible web, right? To get that power into the hands of developers. To expose the DNA, the code base of browsers to developers. So I guess what you've got here is you've got the goal of the extensible web. You've got the principles enshrined. There's a manifesto. There's an extensible web manifesto. And then the patterns we start seeing in things like service workers and web components, which are umbrella terms for these low-level APIs. So the extensible web itself is really just a word, right? It's just a phrase. But words can be powerful. Naming something can be enormously powerful, having something to rally behind. Ajax is just a word, right, for technologies that already existed. But once we had that name, it seemed like Ajax took off. Responsive web design is a label for a group of technologies. When Ethan named it, he did something very powerful there. So naming things is very powerful. Progressive web apps, that's the name for kind of a list of requirements. You've probably heard about them, right? This idea of progressive web app, it's a term that was coined by Francis Berryman and Alex Russell, and you'll hear a lot more about it from Patrick tomorrow. But essentially, it's this list of requirements. Your site's got to be running on HTTPS, and you got to have a service worker so that it's accessible offline, and you have this manifest file which lists, where your icons are and stuff like that. So really, it's just a collection of technologies bundled under this term progressive web app. So again, just a phrase, right? But words can be powerful. And Chrome on mobile will actually use this, if you fulfill this list of criteria, we'll use that as a signal to offer the user to add to home screen, right here. Why don't you add this to your home screen? And then when next time it's launched, it's more like a native app, very powerful. The web and native starting to, get on the same level. That's a really powerful idea. But when I see a lot of the poster children for progressive web apps, I see stuff like this, right? Only works in one class of device. And oh, how the tables have turned, by the way, where you try to visit a site in a desktop browser and you're told, no, come back with a mobile device. It's like a few years ago, we were doing the exact opposite. But this makes me really sad. People are building progressive web apps, but they're doing it, at a separate domain. It's not, instead of turning their existing site into a progressive web app, they silo it off in the same way that we siloed things off from mobile phones a few years ago with our M.dot domains, right? And I thought, didn't we solve this? Isn't this a solved problem? Responsive design. We, instead of sending different devices, different class of devices to different URLs, we have this one canonical URL. This really makes me sad. And particularly the model that, people like Google are pushing in particular is this app shell model where it's like a single page app and you cache the shell and then the content is the last thing to get loaded in. And that's what a progressive web app is. But if you look at the list of requirements for a progressive web app, It's just websites. It's websites that have best practices built in. And I've built what would fulfill the criteria for progressive web apps, and I'm not sure I call any of those things apps. I mean, I've got this site, maybe you could say that that's a web app. I don't even know what that means, but this is like a community website. It fulfills all the criteria for progressive web apps. My personal website, a blog, it's a progressive web app according to the criteria. I put a book online, it's a progressive web app. And even a list of design principles, it's a progressive web app. You can read them offline. So the phrasing, progressive web app, the terminology, we've seen how much power it can have for good with things like Ajax and responsive web design. I'm worried about the power it could have for misleading people, that people might dismiss some of these technologies like service workers and say, oh, that's not for me because I don't have an app, I've got a website. So the words really matter. And something else to bear in mind when you're evaluating a technology is to ask this question: who benefits from this technology? A lot of the time, this will be clearly laid out in the design principles, but there's a whole lot of technologies that don't have design principles visible, right? But there's always some sort of trade-off in terms of who benefits from a technology. And when it comes to web technologies, the way of answering this question is kind of looking on this spectrum between developers and users, who benefits. Like when you go to the website for a particular tool, is it extolling the benefits for users, or is it extolling the benefits for developers? Now, me personally, I always want to look at things that benefit users, but don't get me wrong, I also really value tools that make my life faster, right? Make me work faster, make my life better. And you could argue that any tool that is good for developers is de facto good for users, because as developers, we'll work faster and work more efficiently, and therefore the users will benefit. But I'm talking specifically about technologies that touch the user and technologies that touch the developer. One of my favorite design principles, yes, I have a favorite, in the HTML design principles is the priority of constituencies. It's a classic design principle because it begins, in case of conflict, which is exactly what you want a design principle to do, right, is to establish where to come down in a particular line. In case of conflict, prioritize users over authors, over implementers, over theoretical purity. Users over authors, that's us, over implementers, that's browser makers, over theoretical purity. I like that priority of constituencies. Now, when it comes to evaluating like who benefits from a tool, I think we need to divide our tools, make a distinction between what I call the inward-facing tools, the tools that sit on our computers and help us to write HTML and CSS and JavaScript. But ultimately, what the user gets in the browser is still HTML and CSS and JavaScript, right? These are the tools that are about efficiency, about helping us work faster, helping us work better. Version control systems, build tools, pre-processors, post-processors, all that kind of stuff, right? Now, when it comes to evaluating these technologies, because they don't directly touch the end user, my attitude is use whatever you want. Go absolutely crazy. Use all of these, use none of these, use some of these. It doesn't matter to me because the end user is not touched. Now that's a bit different with the outward-facing technologies, the technologies that directly touch the end user. Now here, there's benefits to us as developers, but there's a price to pay as a user, because particularly with things like CSS frameworks or JavaScript libraries, the user has to download the framework or the library for us, the developers, to get the benefit, right? So there's kind of a tax. The user pays a tax for developer convenience. And you'll be hearing more about some of these technologies over the next 2 days. Ben will be talking about React later this morning. It's a good example of an outward-facing technology, and that's where you need to weigh up the balance. Is the benefit I gain outweighing the tax that the user pays in having to download this thing? Now, when you're evaluating any of this stuff, there's all sorts of questions to ask, like what's the documentation like? That's an important question. What's the community like? Will I be able to get support? What's the browser support like? Super important. File size. What's the file size like, right? All of these questions to ask. Here's one of the things that crops up again and again when I see people deciding whether or not to use a technology. It's something I call the fallacy of assumed competency, which is if large corporation X used this technology, therefore it must be a good technology. This idea that if a large corporation uses something, it must therefore be good, which I always find surprising because if you've ever worked inside a large corporation, that logic does not follow at all. I guess, the fallacy of assumed competency is a bit mean. Maybe a better way of phrasing it would be the fallacy of assumed suitability. Right? Just because a technology is solving the needs of Facebook or Google does not mean it's going to solve the needs of the site or app that you're working on, right? So there's a bit of a logical fallacy there. So don't just adopt a technology only because some large company is using it. However, you don't want to fall prey to this either, right? Not invented here syndrome, where you deliberately don't use a technology because you didn't create the technology and you want to have that control over everything. It's a balance, right? Fallacy of assumed competency, not invented here syndrome, weighing up the benefits, weighing up the costs. So like I said, all these things to consider, again, documentation, file size, community, all this stuff. But the most important question to ask when you're evaluating these kind of technologies is this: what are the assumptions that are baked into the technology? Because I guarantee you there are assumptions baked into the technology. Now, sometimes you can get to the answer to this very quickly because there will be visible design principles, and those design principles make those implicit assumptions explicit. Things like, consider users over authors over implementers, right? That's explicitly saying, here's the assumption that we were working on when we were creating HTML. But most tools ship without design principles, and most tools ship with implicit assumptions, and then it's up to you to try and figure out what those assumptions are. I guarantee you they're there. Now, if you find a tool that matches your own philosophy, then you're going to have a good time. You're going to work with that tool, and you will work faster. But if you're using a tool that doesn't match your philosophy, you're going to clash. You're going to butt heads with that tool. You're going to have a hard time. And this is why you get to this situation where you've got some particular tool, library, framework, some piece of technology, and you got one group of people saying, yeah, this technology rocks. And another group of people saying, this technology sucks, right? And they're both right and they're both wrong, because it totally depends on whether it matches their philosophy or clashes with their philosophy. So that's a key question. What are the assumptions baked into this technology? Because I guarantee you, they are there. Code has assumptions built in because code is written by humans, and humans have assumptions. Humans have biases. Code inevitably reflects the choices, biases, and desires of its creators. We can't distinguish the code from the humans who built the code. We talk about opinionated software. All software is opinionated. Like at work, my colleague Mark has been building this tool, Fractal, and the design principle of Fractal is that it should be as unopinionated as possible. It should be as agnostic as possible when it comes to whatever your build process is or whatever your template language is. It's a tool for building pattern libraries, right? And it turns out it's really, really hard to build something that's genuinely agnostic. Every time you make a decision in the documentation to show an example, you're going to have to show an example using one particular templating language and not another. So you've made a bias there, right? You've favored something over something else. Or just the default settings that you ship your software with. They reflect some assumptions, some biases, right? The defaults matter. It's really hard to make agnostic, unopinionated software. All software is opinionated. Now, I make it sound like the software, the tool ships, and it's got this assumptions built in, it's got biases built in, and there's nothing you can do to fight those assumptions. And that's not quite the same. Once you're aware of the assumptions, you can actually subvert the technology, use it for means other than that which it was intended, right? Technology will find uses that maybe the inventor didn't anticipate. Alexander Graham Bell thought that the telephone would be used to listen to concerts at a distance. Meanwhile, Edison thought that the gramophone would be used to record conversations that people would then listen to later, right? And it turns out those two technologies were used for the exact opposite use cases. I'll give you another example from Hedy Lamarr. Hedy Lamarr, star of silver screen in the first half of the 20th century. She began her film career in Europe, star of many an infamous movie. She was known as the most beautiful woman in the world. She was married to an Austrian industrialist. She would end up sitting in on some of those meetings. They didn't pay her much attention, but she was taking notes, and she managed to escape from Nazi-occupied Austria and make her way to Europe. And she wanted to do her bit for the war effort. And she, together with a composer named George Antheil, came up with this method for guided missiles, for torpedoes, using radio frequency. So this thing, you're guiding a torpedo using a radio frequency, but if the enemy know the frequency or they figure out the frequency, they can jam it. And now you've got no guidance. Well, if both the missile and the people guiding the missile know about hopping frequencies, and you hop to the different frequencies at the same time, you can keep guiding the missile even as you hop around different frequencies, and it's much, much, much harder to jam. Okay, fine. A method for hopping frequencies for guided missiles from World War II. That seems like a fairly specific piece of technology, not really relevant to us today. Every device you have with you today that has Wi-Fi or Bluetooth or GPS is using frequency hopping, spread spectrum. Right? So a technology created for one thing ends up being used for something completely different. Which kind of leads you to believe that technology is there for us to mold, right? That we get to use technology as we see fit. It's Kranzberg's first law of technology. Technology is neither good nor bad, nor is it neutral. But does technology have its own biases? Right? Sometimes it feels overwhelming, doesn't it? I mean, just the sheer amount of technologies. Yes, here on the web, right? Every day there's a new JavaScript library, some new framework we're supposed to be using, some new build tool. What, you're still using that old build tool? Oh, get with the program. Like, this is the new hot build tool. Right? It's overwhelming, so much technology all the time. And it's beyond the web as well. It's just constantly this feeling that the technology is coming and there's nothing you can do about it. Right? This inevitability. And there is this whole school of thought of technological determinism, that there is an end result, that technology does have a purpose, and we're just kind of along for the ride. I think Peter will be showing us some interesting technologies of the future tomorrow. But this is such a disempowering feeling, isn't it? Right? You feel like this stuff is happening. It's a wave of technologies crashing down upon us, and that we actually don't have that much agency. I mean, the ultimate expression of this school of thought is the idea of the technological singularity, right? The rapture for the nerds. This idea, and it comes from astronomy, where you've got the gravitational singularities, right? When a star collapses into such a massive dense point that it's just this singularity from which nothing can escape. And the whole point is that a black hole has an event horizon, and there's literally no way you can see from beyond the event horizon what happens on the other side of an event horizon, right? And the idea with a technological singularity is that technology will evolve so rapidly, so quickly, there will be this event horizon of technology, and we literally can't foresee or predict what's on the other side of that technological singularity. It's a term that's first coined by Vernor Vinge, science and science fiction writer. But I think, looking back at the history of technology, I think we may have already had some singularities. I think we've had at least two, and we're probably living through a third. Because if you look at the agricultural revolution, when we changed from being hunter-gatherers to settling down and farming crops, the lifestyle on the other side of that change was literally unimaginable to the people that came before, to the hunter-gatherers. And then later we had the industrial revolution, and the change in how we live, living in cities, how we live our lives, changing how we structure our days, was literally unimaginable to an agrarian society. And right now, we're having this information revolution. And who could have predicted all the changes that are happening to our everyday lives? But here's the interesting thing. If you look at all of those singularities, agriculture, industrial, technological, informational, they didn't replace what came before. We still had hunter-gatherers after agriculture. We still have hunter-gatherers today. We still have agriculture after the Industrial Revolution. They exist side by side. So I don't think the information technology is necessarily going to replace and change absolutely everything in this technological singularity kind of way. But this feeling of inevitability is there, right? Kevin Kelly is an interesting writer. He's one of the editors of Wired magazine. And he writes quite provocative books about technology with titles like What Technology Wants and The Inevitable. Right? Which at first glance, they sound like they're falling directly into that idea of technological determinism. Right? We're heading towards this technological singularity. But he pointed out that actually, if you're looking at the history of technology, he made this really bold claim that no technology has ever gone extinct. Sounds ridiculous, and he doesn't mean just it's sitting in a museum somewhere, but like somewhere in the world, somebody is using some technology that's long since past its prime. That things just don't replace what comes before, things live side by side. Kevin Kelly, you might look at him and think he looks like he's Amish. He isn't Amish, despite the facial hair, but he would describe himself as Amish-ish. Because when it comes to evaluating technology, it turns out the Amish have a lot to teach us, and they get a bad rap, but they get known as Luddites, right? The Amish have the undeserved reputation of being Luddites, of people who refuse to employ new technology. It's not true. The Amish are steadily adopting technology at their pace. They are slow geeks. And I like that idea of maybe it is inevitable, but we can choose the pace, and we can steer what we decide to adopt, what direction we go in. They ask all these questions, like, is this good not just for me, but is it good for the village? Is it good for society as a whole if I adopt this technology? So I think that we could all do with being a bit more Amish-ish, and I don't mean in terms of how we dress or our facial hair, but in terms of the questions we ask, asking not just how well does this technology work, but also asking how well does it fail? Asking, who benefits from this technology? Is it just me? Is it at the expense of the user? And most importantly, asking of every technology, what are the assumptions? Because when I look at the history of technology, I don't necessarily see this inevitable tide of history created by the technology itself. What I see is history that was created by people. Remarkable people, it's true, but people nonetheless. They created the modern world we have today. And their attitude isn't, it's the future, take it. And our attitude shouldn't be that either. It should be, it's the future, make it. So these are remarkable people, but you know what? You're remarkable people too. You can do amazing things with technology, and for the next 2 days, you're going to hear from some remarkable people, and you're going to hear about new ideas for you to question. You're going to hear about new technologies for you to evaluate. I'm really looking forward to hearing all these talks, and I'm really looking forward to see what you do with those technologies from these talks. So I'm going to get out of the way and listen to these remarkable people. Thank you for your time.